Welcome back to the second video of chapter 2. We've discussed variables in the start of chapter 2 in our Introduction to Java book and its accompanying video, previous chapter 2's first accompanying video. In this second accompanying video, we'll be focusing on more specifics about the variables that we discussed. One of the most fundamental concepts in Java program has always been primitive data types, and they are an essential thing to understand, especially when you're dealing with variables. As you remember, in the variables we always need to state exactly what type of variable we're dealing with, and we need to understand what those types stand for and what they are basically. And that this particular video is going to help us a lot in understanding that part of the variable declaration process that we went through. So when we talk about primitive data types, first we need to understand what are primitive data types, right? So basically we need to remember that in Java, data is classified into two types of data: primitive data types that we'll be discussing right now, and reference data types that we might be discussing later in the book. Today we're focusing on primitive data types, which are basically the more fundamental building blocks of Java variables. We have 8 primitive data types. Each one is designed to store a specific kind of value for us to store basically. So let's explore these types of values. There are 8 values here. As you can see, we have a byte, we have a short, we have int, we have a long, we have a float, we have a double, we have a char, we have a boolean. A byte is a very small value of data. Its storage capacity is the smallest here. Then we have a short, then we have an integer, which is pretty much just any number. We have a long, we have a floating point number, which is basically decimal point numbers. We have a double, we have a char, which is characters, and then we have booleans, true and false. So let's go over each of these and how they work. So first we need to we have the integer types byte, short, integer, and long. These are used to store whole numbers, but they differ in size and memory usage, as I mentioned earlier. So all of them are storing numbers, but the type of numbers they store depends upon the values here. So as you can see here, we have a primitive class which contains the data types here that you can see. We have a small number which is basically a byte, which stores data between minus 128 to 127, which is the only amount of data that it could store. So any number larger than that, a byte data type cannot store basically. Similarly, if you can look at the medium number on line 4, which is 32,000, its range is it can store number up to 32,767, and on the negative scale it can store numbers up to 32,768. Any number above or below these two numbers it cannot save, and we need a different type of data type to store that number. Then on line 5 you'll see an integer, which is a standard number. Here we have a huge number. It seems like this is at least 2.1 billion roundabout, right? So in this number we're also given a range right next to it, which is around to the power negative 2 to the power 31 to 2 to the power 31 on the positive side, right? Similarly, we have a long, which even stores even larger numbers basically. So what we understand from this entire exercise here in these 4 data types example, byte, short, int, and long, is that all 4 of them are responsible for storing data numbers basically, but the difference between them only stems on the amount or the size of data that they can store. The larger the data that we need to store, the largest amount of data we can store is under a long, and the smallest amount of data we can store is under a byte, and the short and int lie in between basically. So as you can see, we understood the more memory, the larger the data type we use, the more memory we consume, and that's what we need to end this particular part conversation on. But at this point we might be thinking that how can we adjust decimal points, because all of these numbers here are not decimal numbers, they're whole numbers, and these 4 data types only deal with whole numbers. They're not dealing with the decimal types. For that we need to basically move on to the other data types that we have, which are floats and doubles. A float is a 32-bit single precision type data, while A double is a 64-bit double precision type of data. It's similar to what we discussed previously in the two other integers, long, shorts, bytes. The difference between floats and doubles is only the amount of data they can store. A float has a limited amount of capacity to store decimal point numbers, while a double stores much larger amount of decimal point numbers. And the difference between them stems in the decimal positions. So a float might be saving numbers up to like 4 or 5 decimal places, while a double would be storing them at least at 7, 8, 9, or 10 decimal places, right? So that's one of the major differences between floats and decimals. In most cases, though, it's preferable if you use a double because it offers more precision. But if memory is a concern in your project about using too much memory, then float might be the better choice. So it's completely up to you. Preferably, if given enough space and if given enough data to maneuver with, a double is a preferable, a more precise data type to use in decimals. But if we have concerns about space and memory, then we move on to floats. So after that, we need to understand about two special primitive types, chars and booleans. And let's discuss exactly how they work. So as you can see on the screen right now, we have a char that stores a single character using single quotes, and boolean represents true and false values, which are perfect for conditions and logic programming that we might need to do. So as you can see, we have a char with a single letter A in quotation marks on line 3, and a boolean is Java fun as true on line 4. Basically, that is all you need to understand about primitive data types. They're the fundamental data types that constitute what data we're storing and what data we process in our Java programs. We need to understand that Java has 8 primitive data types that we discussed: byte, short, int, long, float, double, char, and booleans. Each serves a specific purpose and helps manage memory efficiently. And that's a wrap basically on our discussion on this chapter. We need to understand that at this point we have covered variable declarations and just variable introduction earlier in chapter 2, and now we've discussed the 8 primitive data types that constitute the fundamental blocks of variable declarations that we described previously. If you're following along the book, congratulations, you're moving one more step to get better in Java. And if you're following on YouTube, please don't forget to like, subscribe, and hit the notification bell for more Java tutorials from Smart Architectural Programming. See you in our next video, and happy coding.